How we feeling? Does it like sound familiar to most?
Yes, coming back.
Coming back, right? It doesn't take a while.
I think people tend to forget the plus C.
That is a problem because eventually you don't really use a plus C. As you get into more mature parts of the calculus, you have other things to do. You don't have the plus C. So a lot of times it's like from the beginning of calculus you have to utilize the plus C a lot, and then it goes into you don't use it as much. Yeah. Okay, so
by the exam we won't use it anymore.
maybe once or twice.
Well, ultimately, you would plug in something for C.
Right.
Yeah, you can solve for C.
Okay. Give that one a try.
I remember how to do this. Third period.
I'm telling you, I've seen you dance. No. You may not.
Yeah, Liebler might.
I did.
Liebler.
Liebler likes me. He's got a crush. I told him no more.
He told him no more.
Oh, when he introduced me to his girlfriend, I said, "We're through." All right. Did everybody rewrite it correctly first?
Yes.
Yeah. Okay. So you said
Oh, it's 2x? So, yeah.
Okay.
I was thinking of the other one.
Okay, gotcha. So we're going to rewrite the inside. We're going to add one whole.
Yay.
Mhm.
3 halves.
3 halves, because that's where people get kind of.
1 and a
I
half.
was just
To the add 2 halves.
Yeah. Okay, so if I add 2 halves, I get 3 halves. I'm going to put it over 3 halves. We'll play with that in a minute. And then what's the
2.
2?
And it cancels out with the 2, so now it's just 2x plus 4 to the 3 halves over 3 plus C.
Yes.
Oh, that's very cool. So we have 2x plus 4 to the 3 halves. The 2's cancel over 3 plus C. Feeling good?
Yes.
Yay.
I'm so glad.
This is what I'm good at, is derivatives and integrals, and
This
that's
is what you're good at. I know.
Alright, perfect. Now
But we're going to throw in some sines, cosines, e to the x, and ln of
We're
x.
going to throw in other stuff, yes.
the numbers.
Yeah. Ellen.
When there's no numbers and there's words in
Oh
the
my
map.
God. Well, that's,
volume of the graph.
it would be
Oh,
that.
you moved the crap.
Well, you had to do that. Exactly.
No, that's why I said it.
It sounds like it should be.
Yeah, what did you do in the denominator?
Bring it up. No.
We're doing
Quotient
quotient.
rule. Teach us.
Crying.
No.
Teach us.
Reverse. No.
Oh.
Reverse quotient?
Something special.
Not really.
Not
Oh,
really.
you
What
just
do you?
pull the X up. X
That's what I said. She said no.
Well, you could, but to me it doesn't feel right.
Just take the integral of the top and take the integral of the bottom.
Separate it.
Say a couple magic
X,
words.
well, it'll clarify out or cancel out to 1 plus 4 over X squared.
Oh,
Yeah.
so it's 4 times X and -2, and then you just
Right.
integrate.
Now, if you brought it up to the top and distributed through it, do the same thing, but there's some kind of complication that could arise. You forget to add your exponent when you're multiplying, blah, 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 you know.
Separate, then bring up.
Right,
So it
so
becomes
this is
1
1,
plus.
right? And then this is 4x to the
Negative 2.
-2.
Yeah, I said.
Are we good with that?
That's okay?
Yes.
I just wouldn't think to do that because isn't x squared plus 4 is in parentheses, so you can't pull it apart.
The only way that you can separate it like this is if your denominator is a singleton. If you had 2 things on the bottom, you can't separate those.
So if it was x squared plus 1 in the bottom, then,
You'd be out of luck.
right.
Every piece would go with that. You wouldn't be out of luck, but there's more to this world than that. But for this example, we'd be out of luck.
This is basically saying you're dividing each of the terms on the top.
By that
by the bottom.
singleton on the bottom.
So you can-
Right, right. And you don't want to do that approach if there's 2 things on the bottom.
You would have to bring it to the top.
You do something else. I'll show you. We'll get into that route. So the thing about integrals is every single problem is attacked a little differently. You have to kind of look at it and see the scenario that's happening. You've seen different scenarios so far, and every one of them we had a little technique to get there. This one was the technique that makes it a little easier. Okay, so what's the integral of 1?
X.
X, good. What did we do with that 4, by the way? How did I call it last year?
Goes for the ride.
I said it goes for the ride. Remember that?
Mm-hmm.
And then here, x to the
-1,
over,
-1.
and then we know there's no a and a b.
So it's plus C.
Okay, so if you clean her up a little bit,
X minus 4 over X.
that's it.
Plus it.
With last year, I remember, I don't remember what it was, something, it would go out in front of the integral.
That's what this 4 kind of did.
Oh, okay.
This is kind of like
Right,
having,
it's just going on one.
that's like having this, and then that 4 just came for the rock.
Okay.
So,
Go ahead.
the way we said, could we write it like that? Negative 4 over x?
Right here.
Oh, I didn't see
Yeah,
that.
yeah. I just went backwards. I don't like to go to the right when I'm writing, because then you guys, I'm in front of it. Makes sense, right? Here I am, and I'm writing it, and people are trying to still. I learned that a long time ago when I was pregnant, because I would go ahead and I'd start going this way with it, and then I'd turn around, it'd be all erased. I'd get back. So I figured out that if I kind of go this way with it, I'm not in front of it first and foremost, nor am I erasing it. The butt does it, it all happens. The things you have to think about when you're a teacher.
He's dying
You
back
made
there.
capacity.
Ryan. He was wheezing.
I'm not okay.
Both the
I'm not
Ryan.
okay.
He can just envision.
I'm never
Now,
okay.
How do you
Third
learn
period.
that?
No, 5th period. Like, well,
Need,
I'm not-
money from
we have a test.
something.
Say it again.
Test in the day.
Okay.
Hopefully everybody read.
Well,
I mean, I finished.
I have a test as well for the last 2 periods, but I'm gonna make it tomorrow. That's not, in my perspective. I was like, what was I teaching? I can only imagine if I was forgetting, then they were probably going.
You know what I just realized? That Ty's method is just gonna be like, it's gonna be something that you're gonna teach now.
Forever.
Yeah.
I
And
know.
the first years are getting so lucky.
They are. It's been years.
They don't have to, like, honestly, they don't even have to,
You
like,
should do what you just did, teach the U subway and say, or,
Because there are people that like to use Subway better.
are really?
Yeah.
really?
I use
Yeah.
you sub on the exam.
Yeah.
You enjoy your wasted
Yeah. Yeah.
You enjoy your wasted minutes and
You
precious,
know, your
precious
professor,
minutes.
you might need to know it when you get to college. Your professor might
Me
say.
too. Well, that's
Yeah.
the problem.
Okay.
It hurts to understand why that.
So, let's look at this, guys, for 2 seconds. Let's talk. I'm going to rewrite this, and I'm hoping you guys all agree. Those are the same thing.
Mm-hmm.
Yes.
Yeah, does that make sense?
You just pulled it apart.
I did. I just pulled it apart. Now, remember how I did this over here where I took the x squared and I brought it up and made x to negative 2?
Mm-hmm.
Let's do that here for a second. So I would have x to the,
Negative 1.
and okay, we're cool, right?
It's,
And let's integrate. So what happens?
it's
X to
X
the
to
0th
0.
over 0, which is, well, you can't divide by 0.
Never.
How do you
Yes.
write?
We just broke
undefined?
math.
Undefined.
Okay, so
And it's not the
where do you
0.
write undefined?
Was that a trick question?
There's not a special symbol or anything?
This is not undefined. That's called the null set, meaning nothing's in it.
Okay.
That's totally different than undefined.
Okay.
Undefined means it doesn't exist.
Just write nope. What's the answer? Nope.
How do you write undefined? Is that my trick question for the day?
Why don't you write a skull with X's in its size
That
as
would be
undefined?
undefined,
Yeah.
Or just a really big sad face. Like double circled.
Somebody on skis going downhill. Undefined.
They're about to be.
Okay, so you see the problem. If it looked like this, I could do it. If it looked like this, I could do it. When it looked like that, I did it.
Mm-hmm.
When it looks like this, I cannot. Because I end up with 0 as my denominator.
Mm-hmm.
All right, are we
As
good
long
so
as
far?
there's something left over after you add 1, you can do it.
Because you end up, yeah, you don't have a 0 underneath, right? So this is the only time that we have an issue. Can't happen. But by definition, this is equal to,
Don't bring it back.
now, let's talk for a second. What is the derivative of the natural log of x? 1 over x.
So the integral of 1 over
So
x.
what's the integral of 1 over x?
Natural log
ln of x plus c.
of x.
Okay, so it's on your bright colored sheet of paper, both of them,
That's the cool thing.
right? So the derivative of the natural log of x is 1 over x. The integral of 1 over x is the natural log of x. What they don't do for you is they don't explain why this happens.
No, it actually does have it on there.
But it doesn't explain why, does it?
Well, but like when you see that, you know that means absolute value.
Right. It's because if you were to draw the natural log of x, Okay, let's I think we did this right before. If I plugged in values in here, all right, ln of 1, if I plug in a 1 in, I get 0 for my answer. Okay, so when I plug a 1, I get 0. If I plug in a 2, I get the ln of 2, which is some number. Something, yeah.
0.693.
That's what I thought it was. Okay, good. If I plug in a 3, I get,
1.09
okay, good.
or 1.1.
Okay, if I plug in 0,
Error.
I get undefined.
Ever.
What does that mean? Doesn't exist, right?
Yep.
If I plug in -1,
Undefined.
undefined.
Yeah.
Okay? Okay.
We need a positive.
What happens if I plug in 1/2? 0.5.
Negative 0.69.
Negative 0.693. Okay. What if I plug in 1/4?
Well, 1/3 would be negative 1.9.
Negative 1.38.
Negative 1.38. So what this is telling me is that at 1, 0, I got that, okay? And as I go higher with my numbers, I get a little bit bigger with my numbers. So it kind of grows slowly. And then what happens as I go closer to 0 but not including 0? So 1/2, 1/4, 1/8, 1/12. I go down and I get closer and closer and closer, but never touch it nor hit it, called an asymptote. Okay, so the ln of x, the graph of the ln of x is this. So when I come up with my answer scheme, I know that the x value, whatever I plug in, has to be positive. Can never be negative or 0. Okay? So that is why the absolute value happens. Just an FYI. Okay? So,
It's a given.
it's a given. So the derivative of ln of x is 1 over x. The integral of 1 over x is ln of the absolute value of x. Again, you don't have to have that memorized. Are you okay?
Mm-hmm.
But what you do have to recognize is that it's always going to be something that has a derivative over itself. So let me explain that to you. Asymptote, ASYMPTOTE.
Yeah, I definitely got that right.
I know. You would think that I got it wrong, but it's right, believe it or not. It's one of the things I know. Okay, so anything I have that looks like this, is used in the same regard. In the first place, it can be written as 1 over u du. And we know that the integral of 1 over u, because it can't do u to the -1, right, is going to be the natural log of the absolute value of u plus c. Okay, does that make sense what I just said?
Mm-hmm.
So let me explain what that means. If I want to take the integral of that, that looks nothing like 1 over x, right?
Mm-hmm.
But do me a favor, whenever you have a fraction that you can't split up, like so, okay? I want you to look at this and say, okay, if I make my denominator to be u, and then in my brain I derive it, so what's the derivative of x squared plus 1?
2x.
So do you agree that I have the derivative over the regular thing? I have du over u.
So that's the
Does that make
situation.
sense?
Yeah.
So that is the natural log of the absolute value of u. Well, what's u? It's my denominator.
Mm-hmm.
Okay.
X squared plus 1. Don't forget your plus c.
That's
Literally,
nice.
if you look at your denominator and derive it and you have your numerator there, you're good to go. Yes.
And so you can forget about your numerator. You don't care about that.
Well, yes and no, because we have things, yes.
So that's just if you get a problem where the top is the derivative of the bottom.
Correct.
Okay.
Let me show you something. Is that the bell? Or, I don't know.
Yes.
29, it's 30.
Okay, just give me 1 second. I just want to show you something. Something like that. If I took the derivative of this, what do I get?
2x.
I have 2x there. So what could I do with this problem? I'm good. I could have a split up problem. We'll do that tomorrow.
That's my go-to.
So note to self, always check the denominator is the
derivative.
That's it.
Derivative of-
So like in calculus,